Alright class, so this podcast has to do with calculating hydroxide concentration. So you know that acids all have hydrogen and all bases have hydroxide. And any solution has it's basically a combination between hydrogens and hydroxides. And whichever one is more prevalent or more concentrated, that will tell you if hydrogens are more prevalent, it's going to be acidic. If hydroxides are more prevalent, it's going to be basic. So it's kind of a competing world. If we have pure water, it's equal parts hydrogen and hydroxide, so we have a pH of 7. All right. So this kind of tags along with our calculating pH podcast. But in that podcast, I introduced you to a few equations. One was pH plus pOH equals 14. And then we had two kind of pH equations. One was pH equals the negative log of hydrogen concentration. Alright, and brackets mean concentration, so that's hydrogen concentration. And then the other one was, if we want to solve for hydrogen concentration, it means we know the pH already, so hydrogen concentration equals 10 raised to the negative pH. Okay? So algebraically, if this is true, and our first one is true, this is also true. And this is how we can get concentration of hydroxide. But hydrogen ions times concentration of hydroxide ions always equal 1 times 10 to the negative 14th. Okay? So their product, when we multiply them, always equals this value. And just as a caveat, at 25 degrees Celsius. Okay? You don't need to worry about the temperature, but this is always true at that temperature. If the temperature is different, it's not going to be 1 times 10 to the negative 14th. It'll be a little higher or maybe a little bit lower. But at 25 degrees, this is always true. So with that, to calculate hydroxide concentration, sometimes it'll be a two-step process, other times it'll be a one-step process. So I might give you a question that says, if H plus concentration equals, let's go with 4.36 times 10 to the negative 8th molar, then I might just say, what is the hydroxide concentration? Alright, so the only equation up here that has hydroxide is this right here, which I'm going to kind of circle in red. And what do we need to know in this equation? Well, we always know 1 times 10 to the negative 14th. It's a constant. I want to know hydroxide, so it's really my x. Okay, it's what I'm solving for. So I need to know hydrogen concentration. Alright, and notice in this first example, the problem tells us what the hydrogen concentration is. It says if hydrogen concentration is 4.36 times 10 to the negative 8th, then what is what's hydroxide? So we're going to set this up just like the equation has. 4.36 times 10 to the negative 8th. Alright? And we can leave it in brackets if we want, probably put it in parentheses, but really that times x, which is my unknown, equals 1 times 10 to the negative 14th. Okay? So if my x value is here on the left-hand side, how do I get x by itself? Well, I need to divide by whatever I'm multiplying it by. So I'm going to divide both sides by 4.36 times 10 to the negative 8th. If I divide by that side, or that much on the left side, I also need to divide by that much on the right side. So I'm going to put 4.36 times 10 to the negative 8th. And again, this is one of those places where you have to use parentheses in the denominator. If you remember back from our first unit, whenever you divide by scientific notation, you have to use parentheses, or if you use the EXP button on your calculator, and it'll look like 4.36, second key, comma, just a capital E, and you're just going to type negative 8. So the E means times 10 to the. But you should get an answer of 2.29 times 10 to the negative 7th molar. Alright? So we're wanting a concentration, so molarity is our unit. Okay? The other way I can ask this is kind of the two-part problem. So if I say if the pH equals, and let's say the pH is going to be 10.2, so it's a pretty basic solution. 10.2, what is hydroxide concentration? So same question, but we're just starting with a different thing to begin with. So notice if I'm given pH, can I simply use this equation? I can't, because what's the only thing that can go into this equation? Only hydrogen concentration. So in order to get hydrogen concentration, I need to begin with this equation right here. Alright? So I'm going to first use this equation because I know pH, and with pH I can get hydrogen concentration, and that answer I'm going to then substitute into the second equation. So it's really a two-part question, or two-part mathematical equation. So the first thing I'm going to do is H plus, and H plus always equals 10 raised to the negative pH. And in this case, my negative pH is 10.2. So again, in your calculators, you can put 10 raised to the, or 10 caret negative 10.2. Because it's a negative number, it's going to be a really small value. And in this case, it's 6.31 times 10 to the negative 11th. Alright, and that is molarity. And this, again, is hydrogen ion concentration. So my next equation is, because I know this, I can just substitute 6.31 times 10 to the negative 11th, and I'm going to multiply this by x, and that always equals 1 times 10 to the negative 14th. So how do we get x by itself? I'm going to divide both sides by 6.31 times 10 to the negative 11th. Again, use the EE button, use your parentheses, however you want to do that on your calculator, but make sure the calculator, again, is only as good as the user, which is you. Alright, so the final answer should be 1.58 times 10 to the negative 4th. And again, that is molar. Your calculator might also spit it out 0.000158. And again, either way, it's going to be molar. And again, I don't care if you answer it in scientific notation or in log format. Alright, so that's how you calculate hydroxide concentration.